Multi-step equations, part 3. The last part of solving multi-step equations involves equations where we have variables on both sides of the equal sign. So we want to follow the steps listed below when solving equations with brackets and with equations on both sides. So we want to multiply to remove the brackets, so using the distributive property. We want to simplify wherever possible. We want to collect like terms, and this is where we might have an extra step in here because we have variables on both sides of the equation. And then we want to simplify wherever possible to make our equations easier to solve. And then we're going to start by isolating the term involving the variable by using inverse operations. So we're going to look at adding and subtracting terms first. And then we're going to isolate the variable by using inverse operations. So when we're looking at coefficients in front of the variable by using multiplication or division. So we're going to go through a couple of examples just so that you have some examples to refer to. And you can see different variations of solving equations with the variables on both sides of the equations. So we're going to go through 4 examples, as you can see. And so we're going to start with example A. So example A has 5x minus 3 is equal to 3x minus 11. So this is probably the simplest of the equations that we're going to look at because we have variables on both sides of the equation. We have no brackets though. So we're first going to start by moving all of the variables to one side. So I'm going to start by taking my 3x. Right now it's a positive 3x, so we're adding 3x to the left hand or right hand side. So when I bring it over to the right hand side, I'm going to subtract. So I'm going to have 5x, take away 3x, take away 3 is equal to negative 11. So I've moved it from the right hand side so it's no longer there, and this is what I have. So now I'm going to simplify my terms that have the x, or the terms that have the variable. 5x minus 3x is 2x, minus 3 is equal to negative 11. So the next thing I want to do is I want to move the constant term. So right now it's being subtracted from the left-hand side. So when I bring it over to the right-hand side, I'm going to add. So I'm going to have 2x is equal to negative 11 plus 3. And I'm going to simplify my constant terms. So 2x is equal to negative 11 plus 3 is 8. So now I'm going to divide both sides by the coefficient in front of the x. 2 divided by 2 is 1, so I'm left with x, and 8 divided by 2 is 4. So now I have a value of x is equal to 4, and that is the value that when I substitute it back into the equations, this statement is going to be true. So the left side will equal the right side. We're not going to do the left side, right side check for this first one. We will do it though for our last example, so that you can practice those skills as well. I do suggest that you get in the habit of doing the left side, right side checks for as many, if not all, of your questions so you can verify that you are solving your questions correctly. And if your left side, right side checks don't equal, then you've done some sort of calculation error within your question that you need to go back and find. And if you have any questions, please put them in the discussion board or send me an email. So now let's take a look at example B. I have 6n minus 2 is equal to 10n plus 14. So normally I would move my variables to the left-hand side, but in this case I'm going to move it to the right-hand side only because I have only because the 10 is greater than my 6. And this will allow me to have a positive value for my coefficient. So that's just a strategy if you want to eliminate some negative numbers in front of your variables. That's something that you could do. So I'm going to start by taking my 6n Right now it's a positive 6n, so it's being added to the left-hand side. So when I bring it to the right-hand side, I'm going to be subtracting. So I have negative 2 on the left-hand side is equal to 10n take away 6n plus 14. I'm going to simplify what I have on the right-hand side. 10n take away 6n is 4n plus 14. So now I'm going to move the constant term. Right now it's being added to the left or right-hand side. So when I bring it to the left-hand side, I'm going to subtract. So I have negative 2 take away 14 is equal to 4n. Negative 2 subtract 14 is negative 16, and that's equal to 4n. And now I'm going to divide by the coefficient in front of the variable, and I'm going to do that to both sides. So I'm going to divide both sides by 4. Negative 16 divided by 4 is negative 4. 4 divided by 4 is 1, so I'm left with n on the left-hand or right-hand side. So now I have a value for n. N is equal to negative 4, so you can keep it like this, or if you want to rewrite it so that your variable is on the left-hand side, you can do that as well. And this is the value of n that'll make this statement true. So the last two examples involve some brackets. Obviously, the example C is just a smidge easier than our example from D, but we're going to apply similar properties. So we're going to get rid of the brackets by using the distributor property. So I'm going to have 3 times x is 3x. 3 times 2 is positive 6. And that's equal to 5x plus 8. As you're doing your questions, I really want you to pay attention to how you format your solutions. And I really want you to aim to try to solve your solutions in a manner that I'm showing you here. So now I want to move my variables to one side and my constants to the other side. And I'm going to show you what it looks like if you move your variables to the left-hand side with a negative coefficient. So I'm going to start by taking my 5x. Right now it's being added, it's positive to the right-hand side. So when I bring it to the left-hand side, I'm subtracting. So I have 3x take away 5x plus 6 is equal to 8. 3x take away 5x is negative 2x plus 6 is equal to 8. I'm going to move my constant term over to the right-hand side. Right now it's being added to the left-hand side, so when I bring it over, I'm going to subtract. So I have negative 2x is equal to 8 take away 6. Let's simplify our constant terms. 8 take away 6 is 2. And now, because I have a negative coefficient, when I divide both sides by the coefficient in front of the variable, I also want to divide by that negative number as well. So I'm going to divide both sides by negative 2. So if you move all of your coefficient or your variables to the left-hand side and your coefficient in front happens to be negative, this is a way to work that out. So negative 2 divided by negative 2 is positive 1. So I'm left with just x on the left-hand side, and 2 divided by negative 2 is negative 1. And so that is the value that'll make this equation true. So x is equal to negative 1. So the last example that we're going to go through still involves variables on both sides of my equal sign, but now I have a distributed property on both sides that I need to take care of first. So I can multiply out my distributive properties all in one step. So remember, if there is no number in front of the bracket, it's like an imaginary number 1. So I'm going to be multiplying everything inside of my bracket by the negative 1 in my second bracket. So I have 9, and then negative 4 times x is negative 4x. And negative 4 times 2 is negative 8. So I've eliminated the bracket on the left-hand side. And I'm going to do the same thing to the right-hand side. So I have 2 out front. And then negative 1 times x is negative x, or negative 1x. And negative 1 times negative 8 is positive 8. So the first step, I have eliminated my brackets. Now I'm going to simplify before I move any further. So I have negative 4x on the left-hand side, and 9 take away 8. So I'm just collecting these like terms so far. 9 take away 8 is 1, so plus 1. And that is equal to, on the left-hand side, I have negative x, and then 2 plus 8 is 10. So I've just simplified my terms before I move any further. So now what I want to do is I want to move all of my variables to one side and all of my numbers to the other side. And again, it doesn't matter which side you move your variables to. We can move it to the left-hand side if you want to have that sort of consistency. So I'm going to take my negative x on the right-hand side. Right now, it's a negative value, so it's being subtracted from the right-hand side. So when I bring it over, it's going to be a positive. We're going to add it. So I have negative 4x plus 1 is equal to 10. Negative 4x plus x is negative 3x. And what I can do is I can show this next step, or I can just write it down and then move it next. So I'm going to take my plus 1. So right now it's being added to the left-hand side. When I bring it over to the right-hand side, I'm going to be subtracting. So I have negative 3x is equal to 10 take away 1. 10 take away 1 is 9, and now I have to divide both sides by the coefficient in front of the x, so I'm dividing both sides by negative 3. Negative 3 divided by negative 3 is 1, so I'm left with x on the left-hand side, and negative 9 divided by negative 3 is negative 3. So that is my value for x. And if I wanted to do a left side, right side check, so I'm just going to draw a line here, and I'm going to do my right hand side check right here. So left side and right side. So there's my t-chart. Just going to draw another line there so I don't get things into that space there. So my left hand side is 9 take away 4 times x plus 2. My right-hand side, is 2 take away bracket x minus 8. So I'm going to substitute the value of negative 3 into my x. So I have negative 3 plus 2 inside of my bracket. On the right-hand side, same thing. I'm going to substitute my negative 3 in place of my x. So now I'm going to simplify this using order of operations, so using BEDMAS. So I have 9 times 4. I'm going to simplify what's inside of my bracket. So negative 3 plus 2 is negative 1. So I have 9, and then negative 4 times negative 1 is positive 4. And 9 times 4, or 9 plus 4, is 13. And on the right-hand side, let's simplify this. I have 2 take away. Negative 3 subtract 8 is negative 11. And when I have a negative sign, I can think about this as multiplication, or I can just know that when I have two negative signs right beside each other, it becomes a positive. So there's lots of strategies that you can use to simplify that. And 2 plus 11 is 13. So my left side equals the right side, which is what I want. So now I can say with certain left side equals the right side, therefore x is equal to negative 3. So you can get in the habit of doing those left side, right side checks for especially those complicated equations to make sure that you've done it correctly. As you can see, I didn't do it for all of the ones on this lesson, but you could have done it for every single equation on this sheet to verify that your solutions are correct. So as I said before, if you have any questions about solving multi-step equations where the variable is on both sides of the equal sign, please throw your questions up on the discussion board and within the virtual learning environment or send me an email.